Well, I think we're ready to start working on some actual content from today's material. For today's walkthrough, I'm going to be using the Excel file, but again, choose whichever format you like as you follow along. And one other quick note that you might be wondering with these assignments is how much you ought to do alone versus following along with me. Generally speaking, I'd like for you to do as much as you possibly can independently, and then afterwards, check with my solutions in these videos to see if you've done it right. But within each video, I will try to provide some guidance as to what I think you ought to be able to do on your own versus when you ought to just follow along and do the practice with me. So let's go ahead and get started with number one here. A company expects to pay $30,000 4 years from today to replace manufacturing equipment. We've got a 9% annual discount rate. So we have three different discount factors that we can choose from here. Because this is one single lump sum payment in the future, we're going to use that first discount factor, the present value of $1. Of course, we're specifying the number of periods is 4, the annual interest rate is 9%. So in this box, I will type equals $30,000. That's the size of the cash flow times the discount factor gives us our answer of roughly $21,000. Now, some of you might be really good with your Excel functions and you want to do something like equals PV, a present value function. And we specify the interest rate, the number of periods. There's no payment here, just a future value of $30,000. Now, obviously, that gets you the same ballpark. It's as good an answer as the other. But on the exams, you're not going to have these Excel functions at your disposal. So I do ask you to go ahead and learn how to do this with discount factors. You'll see on the CPA exam, they give them to you in the same format. So good to start practicing now. Let's move on to number two. A company expects to receive $14,000 at the end, which has been underlined, at the end of each year for 5 years from a licensing agreement. The first cash flow will be received 1 year from today. So again, I'm really trying to hit you over to the head that the first cash flow, 1 year from today, and they occur at the end of each period. That's important because we've got, that discount rate of 6%. As we're choosing our discount factor, we know this is either going to be an annuity versus an annuity due. But annuities are classified as those incremental cash flows occurring at the end of each period. So for this one, we will take $14,000, multiply it by 4.212, present value of a $1 annuity, and get our answer of 59,000 bucks. Number three, do you think you can try doing that one on your own? I invite you to pause, take a stab, and then check with my solution here in a bit. Okay, a lease requires 6 semi-annual payments of $9,000. The first payment is due immediately at lease commencement, and the remaining payments are due at the beginning of each 6-month period. That's a pretty common arrangement with leases. The first payment is due at the contract inception. The annual interest rate is 8%, but it is compounded semi-annually. So we have 4 discount factors we can choose from here. Either those of an annuity versus an annuity due, and then the other variable is what number of periods and interest rates we ought to use. Because these payments occur at the beginning of each period, we need to use the present value of an annuity due. Now, hopefully with 6 payments, you can look at that n equals 6 and have a pretty good idea of what we need to use there. But it's also critical that when you see I equals 4%, that's half the annual rate. That's the correct one to choose here. So the present value is going to be the $9,000 lease payment times 5.452. And to take a quick step back, how has discounting these future cash flows been reflected with that discount factor? The alternative is that we just take all six $9,000 payments at face value. If we did $9,000 times 6, the raw dollar amount is $54,000. But in today's value, it's only about $50,000. Okay, last one. This one's a little tricky because it involves 2 discount factor calculations. If you could solve this one on your own right now, that would be awesome. But if not, just hold tight and I'll present the solution here shortly. Number 4, a machine is expected to produce net cash inflows of $18,000 at the end of each year for 5 years. Sounds like a string of equal-sized recurring payments. The machine is also expected to be sold for $25,000 at the end of year 5. We've got the appropriate annual discount rate of 7%. To solve for the present value, like I said, we need to do 2 separate calculations and add them together. And I'll start with the $18,000 expected to be produced at the end of each year for 5 years. So I'll multiply this $18,000 by the present value of a $1 annuity. 4.1, and then I'm going to add this. Order of operations will preserve the calculation correctly here, right? We've also got a $25,000 lump sum 5 years in the future. So I'll take that 25 grand and multiply it by the present value of $1 in the future, 0.713. And there we've got the correct answer there. So again, today's material is pretty straightforward. We're not going to push this one too heavily, but it will be useful later on in the semester if we're solid with our time value of money concepts. The last thing I want to show you is actually submitting these assignments. I would encourage you to save this by putting your last name at the end. And let's now go to Canvas, where if you scroll down, this is where you can upload specific files. You can see the different file types I'm permitting. So if you worked with the Word document, you could just upload that finished file with your notes on it. Maybe you saved as a PDF. You can also submit a complete Excel file like the one we just worked through. Or if you're just taking notes separately on a sheet of paper, take a picture of what you've done and upload either a PNG file or JPEG. So here, we'll click the button. I'll find the one with my name at the end of it, and then go ahead and submit the assignment. Great job, everybody.